Good afternoon. A continuation of adding and subtracting polynomials. Our objective is students to add and subtract polynomials. A quick one at our check question. Determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it is a monomial, binomial, or trinomial. I explained that when an expression has a negative exponent, it is not a polynomial, because this can also be written as 3 divided by z exponent 3, and when it is being divided by a variable, it is not a polynomial. So we say not a polynomial. The degree is no degree and no classification. B, 2x to the power 3. It all has a positive exponent, so it makes it a polynomial, and the highest degree is 3, and it has 3 terms. So 3 terms, we say a polynomial, 3, and the classification as a trinomial. 9b is a single expression, and it is a monomial, and a degree of 1. And of course, if it is a monomial, it is a polynomial. 9x minus 2. X has an exponent of 1, so it means that our degree is going to be 1, and our classification is going to be a binomial, and it makes it also a polynomial. Let us look at these examples. Our highest degree is 2, no negative, so in that case it becomes a polynomial and 3 terms, so it makes it a trinomial. So our answer is C. This has an exponent of negative 2, so in that case it doesn't make it a polynomial, so our answer is D. Now let us write polynomials in standard form. Writing polynomials in standard form, you have to find the degree of each term. That is our first step. So the same question written down, writing the degree. 4x has a degree of 1, 12 has a degree of 0, 2x exponent 3 has a degree of 3, and negative 3x squared has a degree of 2. So in writing this from the expression with the highest degree, we can say 2x to the power of 3 should be our first, and our second will be negative 3x squared, and our third is plus 4x, and our last is plus 12, and it is written in a standard form. Now to write the leading coefficient, I'm going to write it as LC. Now the leading coefficient is the coefficient or the number attached to the number with the highest degree, so which is 2. So our leading coefficient is 2. We move on to the check question on page 546. Write 5b minus 10b squared plus 35 minus b exponent 3 in standard form. So finding the degree of each term, 5b has a degree of 1, minus 10b squared has a degree of 2, and 35 has a degree of 0, minus b exponent 3 has a degree of 3. So in rearranging from highest to lowest, we have minus b exponent 3 followed by minus 10 b squared followed by plus 5b, and the last one is plus 35. Good. Now our leading coefficient LC is the number attached to the variable or the expression with the highest degree, which is negative 1. So write this expression in standard form. So it means we should identify this comes first. So this is our 1, followed by that 2. Then the next one is 3, and the last one is 4. So 3 first, so we can see that this and that. So these 2 answers are out. Now the next one is 9. So the next one we have 9, we have 4, so this is out, and in that case A is definitely going to be our answer. B, identify the leading coefficient. Now in writing this 5, I'm going to write them again. Now what we are looking at is when it is written in a standard form, we are identifying the leading coefficient. So we have to write it in a standard form by looking at the one with the highest degree. 5m, let me write them again, 5m plus 21 minus 6mn plus 8m n3 minus 72 n3. This has a degree of 1, 21 has a degree of 0, m has 1, n has 1, so we have 2 here, m has 1, n has 3, so we have 4, and n has 3. So looking at that, this comes first, 8 m n to the power of 3, followed by minus 72 n3, followed by minus 6 m n, then plus 5 m, then plus 21. So our leading coefficient here is the 8. So in that case, B becomes our answer. Now adding polynomials. In adding polynomials, there are two methods. We have the vertical and we have the horizontal. Horizontal is the x-axis and vertical is the y-axis. So in that case, using the horizontal method, I'm using the color to explain first. Now 3x squared can only be added to 2x squared, and 9x can also be added to 4x. You cannot add 3x squared to 4x. So in grouping like terms, we're going to have 3x squared plus 2x squared. Then with the green we have 9x plus 4x, and the last one we have 27 plus minus 12. I put the minus 12 in the bracket so it doesn't confuse you. Now in combining them, we have 3x squared plus 2x squared will give us 5x squared. The 9x plus 4x will give us plus 13x. And the last one, don't forget that positive and negative takes over. So 27 minus 12 will give us positive 15. And that is our answer. And this is written in a standard form because this is first, followed by the second and the third. In the vertical method, you have to arrange it vertically, and that is very easy. It makes it very easy. You see, red to red, green to green, and blue to blue. So 3 plus 2 is 5, x squared, we put our x squared there. Now the next one we have plus 9 plus 4 is going to give us 13x, and 27 plus minus 12 is still going to give us positive 15, and this is also written in a standard form. Good. So let us look at this. We can use different ways of solving the horizontal and the vertical. So the horizontal, we have two terms for each. So 3x squared plus x squared. And the next one, so our plus comes in between. We have minus 4 and minus 9. So minus 4 plus minus 9. Now this 3x squared plus x squared will give us 4x squared, and minus 4. Now positive and negative, we have negative. So minus 4 minus 9 will give us minus 13. Now you can continue to do for the vertical method. Now let us do it together. We have 3x squared minus 4 plus x squared minus 9. So this gives us 4x squared, and minus minus, because positive and negative we still have negative, so minus 4 minus 9 will give us minus 13, and that is our answer. So we still arrive at the same. Now this is a binomial and a trinomial. So in arranging, you have to do it in a standard form first before you add. So writing this in a standard form, we have negative x squared plus 8. We just this first, this has 2 and this has 0, so this first. Now the second one, in writing this in a standard form, we have 2x squared plus 4x minus 9. Then now you can use any of the method. So I'll prefer using the vertical method. So vertical method, I have negative x squared plus 8. Then our plus comes. Then now I arrange this the same. We have 2x plus 4x minus 9. Now this 8, I can put 0 here and bring our 8 on this side, because there is no variable with an exponent x, so there is no constant with x, so I can just put 0 there. It's still the same. So in solving, there's negative x squared plus 2x. This is negative 1x, so in solving that, we are going to have x squared, and this remains plus 4x and positive 8 plus 9. Sorry, positive 8 minus 9 will give us negative 1. So we can continue on page 548. We can solve this question on our own. We can arrange it. It is already arranged in a standard form, so using the vertical, we can solve using the horizontal way. So we're going to have 6x minus 11 minus 2x minus 19. Now 6 minus 2 is 4x, and minus 11 minus minus, so this minus and minus becomes plus, so minus 11 plus 19. What are we going to have? It's still the same as 19 minus 11, and we have negative, it should be positive 8. Good. And that is our answer. So using the vertical method, same way you have to arrange the second expression in a standard form. So we're going to have negative 3x squared plus 7x plus 14. So using the vertical method or the horizontal method, we have, I'm using the vertical x plus 2. Now in writing the second term, I do not have x as an exponent for the first term, so I'm going to bring this negative 3x squared, then my plus 7x comes directly under x, and plus 14. So what we're doing is we are subtracting. So in subtracting, so 0 minus minus, so I can put 0 plus x here. So 0 minus minus 3 will give us this negative, and negative makes it positive. So we are going to have 3x squared, then x minus 7x. X minus 7x will give us negative 6x, and 2 minus 14 will give us negative 12, and that is our answer.